So in the last video, we covered properties of the definite integral, and what I want to do now is use some of those properties. So we're going to make some assumptions about the integrals of different functions here. We don't know what f of x looks like. We don't know what g of x looks like. I don't have a graph or a table or anything like that to look at. I just have some information about the areas under these curves over specific intervals. So we know that the integral from -1 to 5 of f of x dx is 10. The integral from -1 to 5 of g of x dx is -4. And we are asked to find the definite integral from -1 to 5 of this more complicated looking function, 2f of x minus 5g of x dx. I don't need to know what that looks like in order to answer this question. One thing you might notice is that we're using the same functions that are shown here, f and g, and then we're also integrating over the same limits of integration, -1 to 5. If you'll notice, a lot of these properties that involve combining integrals to produce new integrals, we keep the limits of integration the same. So that's what allows me to use some of these properties. Let me start with this. The integral from -1 to 5 of 2f of x minus 5 g of x dx. So first of all, it's a difference between two functions. Property 3 says that if I have a difference between two functions, I can represent that as a difference between the integrals of each function. So I can split this up and write it as the integral from -5 to 1 of 2f of x dx, that's a weird way to write a minus the integral from -1 to 5 of 5g of x dx. Now, in addition to that, not only do I have these functions f of x and g of x appearing, but they're also being multiplied by constants, 2 and 5. I have this property here, property 4, that says if a function is being multiplied by a constant, you can pull that constant out of that integral. So this is equal to 2 times the integral from -1 to 5 of f of x dx minus, pull the 5 out, integral from -1 to 5 g of x dx. Now, these integrals, I already know what each one of these integrals are equal to because that was given to me in the problem. This integral is equal to 10, and this one is equal to -4. So we put those values in. This becomes 2 times 10 minus 5 times -4. This is 20 minus -20, which is 40. Okay? So notice we evaluated that just by using the given information and using properties to break the integral down into manageable chunks. Okay? Okay, this problem is similar in the sense that we want to split this thing up into manageable chunks, but this time instead of being told what the integral of specific values is equal to, we are given graphs of these functions, so we have to come up with the areas that correspond to this ourselves. So I'm going to do a couple of steps in one. Here's what we're trying to evaluate. Okay. Using those properties, for one thing, I can split this into a sum of integrals, so -2 to 5 f of x dx plus, now this guy is going to be the integral from -5 or -2 to 5 of g of x over 3, which is the same thing as 1/3 times g of x, and we know that that 1/3 can be brought out of that integral. So I'm going to do that all in this step. Okay? At this stage, we have a couple of integrals here that we want to evaluate, and understanding that they represent areas between a curve and the x-axis, I can use the graphs to determine what those are equal to. Both integrals go from -2 to 5. So let's start here. Here's -2, here's 5. Okay, so -2 to +2 represents this area right here. And then from +2 to +5, I have a triangle. So what I want to do is figure out what is this area. Well, if you think about it, that's actually a rectangle from which we subtracted a semicircle. You start with a rectangle and you cut out a semicircle, and whatever's left of that rectangle is the area that we want. So let's see if we could figure that out. The integral from -2 to 5 of f of x dx is equal to that area. Starting with the rectangle, it would be, let's see, it's a 4 by 2 rectangle. So that's 4 times 2. But then we want to subtract the area of that semicircle. So remember, the area of a circle is pi r squared. In this case, the radius is 2. You can see that this is what the center of the full circle would be. 2 units away is the